We live in an age where big data is everything, right? The common wisdom is that more information is always the answer. But what if it's not? Today, we're going to dig into some really fascinating research from the high-stakes world of finance that flips that whole idea on its head.
So let's just start with the big, kind of crazy question. In a world that is completely obsessed with collecting every single byte of data we can get our hands on, is it even possible that adding more data could actually make our predictions worse? It sounds wrong, but stick with me.
You know the drill by now. This is pretty much the gospel of the modern tech world, especially in finance. The thinking goes like this. You get a gigantic pile of data, you feed it into some super smart machine learning algorithm, and voila! You get these incredibly accurate predictions about, say, who's going to pay back a loan and who's not. That's the dream. And you can totally see why this is so tempting, right? I mean, the promise is huge. The idea is that with enough data, we could spot these subtle patterns nobody's ever seen before, get way better at predicting defaults, and maybe even open up credit to people who were ignored by the old systems. It paints a picture of a smarter, more efficient, maybe even a fairer financial world.
But right when we're all nodding along, thinking, yeah, makes sense, there's a twist. It turns out that this mad dash for more data, for bigger and bigger data sets, comes with a pretty serious and often totally overlooked hidden danger. And that danger has a name. It's called model risk. Now, this is the really interesting part. We're not talking about the risk of something happening in the real world, like a borrower not paying their loan. No, we're talking about the risk that the tool we're using to make the prediction, the model itself, is broken. Or, and this is key, is being used in the completely wrong situation. Okay, this breaks it down perfectly. So, credit risk, that's the classic question. Will this person pay me back? Simple enough. But model risk asks a totally different question. Is my fancy computer model for figuring that out actually any good? Think about it like this. Imagine you have a perfect, flawless, incredibly detailed map of London. It's a masterpiece of a map. But if you try to use it to find your way around New York City, you're going to get lost. The tool is perfect, but the context is all wrong. That, right there, is model risk. So, to really put this idea to the test, some researchers set up this amazing real-world experiment. And the proving ground for this whole thing? Sao Paulo, Brazil, a massive city, a perfect place to see if the more data is better theory holds up under pressure. And when I say high stakes, I mean it. The sheer scale of this thing was just wow. They analyzed a dataset with almost 160 million separate loan observations for small businesses. I mean, think about that. That's not just big data. That is a colossal amount of information. We are way deep in the data ocean here. So with all that data, they could ask a really sharp, specific question. Let's say you're Bank A. You want to predict which of your customers are going to have trouble paying you back. What's the best way to do it? Should you build a model using only your own data from your own customers? Or should you go big and build a super model using your data plus all the data from every other bank in the entire system? And this set up the perfect showdown. In one corner, you've got the population model. This is Team Big Data, using all the data from all the banks. And in the other corner, you have the segmented model. This is Team Focus Data, using a much smaller, specific data set from just one bank at a time. So, who wins? Now, to keep score, the researchers came up with this really clever metric. They called it Credit Scoring Model Risk, or CSMR. And the idea is just brilliant in its simplicity. Think of it like a golf score for your model. A score of 0, that's a hole in one. Your model is absolutely perfect. A score of 1, well, that means your model is totally useless. You might as well just be flipping a coin. So the lower the score, the better. So what happened? The moment of truth. When they actually ran the numbers, the result wasn't just clear, it was a total shock. The segmented model, the one built with less data from a single bank, consistently got a lower model risk score. I'll say that again. The approach using less data was actually more reliable. The big data model was riskier. And hey, don't just take my word for it. The researchers themselves put it about as bluntly as you can. Their work basically pulls the rug out from under one of the biggest assumptions of our data-driven world. Okay, so this is the real million-dollar question, isn't it? We know what happened, but we have to understand why. How on earth could a model with less data actually beat a model that had so much more information to work with? It just feels wrong. And the answer really comes down to two words. Context is king. See, what the researchers realized is that every single bank is its own little universe. They have different kinds of customers, they have different rules for lending money, different appetites for risk. And when you just dump all of that unique, different data into one giant pot, the population model, you actually average out and obscure all those important little details. The sheer quantity of data starts to hide the quality and relevance of the data that actually matters for a specific bank. And the implications of this are huge, for everyone from the banks themselves to the regulators trying to keep the whole system safe. So, in the end, the lesson here isn't that data is bad. Not at all. It's that our obsession with more might be leading us down the wrong path. Maybe the real challenge, the question we should all be asking, isn't how can we get more data, but rather, what is the right data? Thanks for digging into this with me.